Would you apostrophize the S?
All right, here, I'm going to burp real quick.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 100. Today we're talking about an Arduino that plays CDs, virtual reality in the 60s, and a magical linear actuator. 100th episode.
No, episode number 100.
Ep100.
Episode 100. Our 101st episode. Buffer overflow.
Ah, the new year, Elliot. Welcome back.
Yeah, Happy New Year, Hackaday.
It's weird taking a couple weeks off from, taking one episode off from
1 week.
I was getting ready today. I'm like, I don't know if I remember how to do this.
Yeah, right? What are we doing here?
And then you actually took some time off from Hackaday in general between Christmas and New Year's. How was that for you?
We call that vacation. And It was awesome. I had a really good time. I came into Hackaday one time to read up and, because I read Hackaday every day, and I found myself editing one of the posts. And I'm like, okay, that's it. I can't open Hackaday for the next 2 weeks. So I actually didn't. And I spent a lot of time with my family, which was awesome. And I spent a lot of time building version 2 of my hot wire cutter robot, which was awesome. Then, for no good reason at all, I decided I would write the software to drive it. So that was super fun.
Well, it's one of those things where you start working on it and you're like, oh, I'm close to finishing this. I could just power through it.
I built it once and I had it running and it made some decent planes, but I just didn't like it. Had some wobbles in it and I knew I'd underbuilt it. I'd built it to see how little I could do, actually. And the answer was it was too little and it was too wobbly. So I built it a lot stronger this time, in kind of all the obvious ways. And it worked a lot better. So kind of duh. But there you have it. When you build machines like this, half the fun is then figuring out how to drive them afterwards. And so I spent at least one good night playing around with tangents and going from XY to polar coordinates and back because I had to do some funny rotations and projections and things like that. And so, it's good time with a pen and paper and then typing Python. Like you do, right?
Yeah, well, and you said you did a bunch of test cuts with it, so what do you think?
Oh, I'm done with test cuts. This thing is awesome. But you have to picture me in my basement cutting things out of styrofoam and then taking calipers to them afterwards and seeing if I got all the dimensions right.
So when you do 3D printing, you would maybe print a calibration cube to see if the dimensions in all directions are the same. Were you cutting calibration cubes?
I started off actually cutting circles. Yeah, good point. I was cutting cylinders, and then I went to cutting wings that were symmetric. So they had the same airfoil on kind of the root and the tip of the wing. And then I started cutting them where they were, where it thinned as it went across the length of the wing, and then twisted, and then different profiles entirely on both ends. And then the thing that I had to spend a lot of time with trigonometry again was putting a cutout for the aileron at the back of the wings. So I'm making these wings out of styrofoam, and the wire needs to take a little dip at the end to almost cut through, but not quite cut through the styrofoam so that you can get a bendy flap at the back end of the wing. And it's now doing that automatically, which turned out to be a non-trivial synchronization problem between these two-axis bots to make that line go straight across the back end of the wing. And that took a lot of thinking on my part, but these are also problems that are all solved. You can buy software to do this for you for sure. And I think there's a couple open source projects to do it, but I don't know. Where's the fun in that?
I didn't do very many projects. I've been doing a lot of video gaming lately, and that's been enjoyable. But I did finally get a deal on a portable hard drive, like a USB 3 in a case. It's like a 2.5-inch hard drive in a case, which I've never had one of those before. They're pretty cool.
Cool.
And I just plugged it into my router. I'm running OpenWrt. Getting that up and running was a little bit of an adventure because you just got to install some packages. But then I was like, I want to back up basically my root partition, and I don't want anyone on the network to be able to get into that backup file. And so how do you do that? And I looked around for a while, setting up Samba to have authentication didn't seem good. Setting up NFS was really easy, but getting it to do authentication, I couldn't work my way through it. I ended up doing SSHFS.
Okay.
so that you just put a public key over there and it grants permission for your computer. So I think that was a pretty good way to do it. I still don't back up my root partition because I installed the drive and got it auto mounting, but I haven't set up an rsync task to actually back up the root partition. But that's the next step, little by little. It's a new year. New backup methods are a good idea. Well, what do you have on your list of hacks, Elliot?
Okay, starting off, I have Daniel 1111's an Arduino and a CD-ROM drive make a CD player. I don't know why I love this one so much. I just think it's awesome. It starts off with a computer CD player, like those old ones that you used to install in your towers. And he wants to make it an audio CD player, and he wants to do it himself. Sending the controls to these things is easy enough because the ground has already been blazed by the Arduino project, where ATtiny is it's the protocol spoken over the IDE connector that tells CD-ROMs what to do. And ATtiny stands for...
I have no idea.
Another terrible acronym, probably interface, right?
It's not like ATA API.
It's ATA parallel interface?
PI, okay.
It must be, because it's a super parallel interface.
Right.
Anyway, it's one of these old interfaces that runs over an IDE cable. And so the Arduino project uses a bunch of I2C expanders to get the super parallel data stream out of an Arduino for this. And then Daniel's project takes that one step further. He takes the audio out of the CD player, which comes out of one of these SPDIF streams, and then decodes it and runs it through an amplifier. I guess what I thought was awesome about this was just the way, with a couple chips these days, a couple properly selected chips and a small PCB, you can do all of the control logic that like your desktop computer would have done to make it play audio CDs. And then decoding SPDIF is fantastic. I mean, like that sounds super impossibly difficult, but the answer is you just buy the right chip and you plug it in there and it handles it. And then you put that off to a DAC and, all of a sudden you're listening to CDs as if they were played by a computer, except it's all driven by an Arduino.
So if we pronounce it out, that SPDIF output, like if I remember right, back in the day, you would have a line running from the back of your CD-ROM drive to your Sound Blaster card. Right?
Yeah, right? So in the really bad old days when data was hard and making computers crunch numbers was expensive or something, you would actually have an audio out on these things, and that would run into your sound card and out so you could hear it. And that's actually what the Arduino project does. What Daniel adds to this is this whole kind of SPDIF to digital audio conversion layer on the backside. And I don't know. I just thought that was charming.
If you're having trouble picturing this, I mean, think of a full-size CD-ROM drive, like you'd put in a tower, like Elliot said, and just adding a circuit board on top of it that turns it into a Walkman. So it's got a little LED screen and buttons on it, and that's exactly what it is. Can you walk into like a Target or a Walmart and buy a portable CD player these days?
I bet you can. I bet you could walk into like a Salvation Army and buy one cheaper though.
Right. Yeah. I don't know. My desktop drives, CD drives, always tended to break. Like from one computer upgrade to the next, I usually needed a new drive.
Yeah, they're horrible. And the worst is those various burners, right? They'll always get slightly misaligned and then they'll write CDs that only they can read from now on. Did you ever have that? I had one. It was a TDK. It was a DVD burner drive, and it would make DVDs that only it could read.
When we moved out of our apartment, like 2010, we still had CDs, and we bought those folders, the zipper cases that you can put them in, and we got rid of the jewel cases so that our thousands, my wife and I are musicians, so our thousands of classical albums and our, formidable collection of non-classical albums were just all into one bin in these zipper pouches, and it's gone and sat in the basement forever. And I'm sure there are some burnt discs in there too that now have been sitting there for 10 years. I should pull those out because they say you can't read them anymore, the writable discs, because they have organic dyes for the medium that end up having kind of a shelf life to them.
If they've been stored cool and dark, I bet you're okay.
What about humid and musty?
I don't think humid bugs them. As long as they're cool and dark, you're going to be fine. Don't worry about it, man. But get them off that medium as fast as you can if you care about them.
Yeah, I mean, some stuff like recitals that I presented as part of my college degrees, I don't have, that's the copy that's down there. So I guess stuff like that would be nostalgic. Everything else, I don't know, like backup files from Windows 2000.
There's a certain value to forgetting. I think a lot of times people are like so caught up in archiving, they forget that the most important part of archiving is selecting what you archive first. And like that kind of pruning and curating, that's actually A, the hard part, and B, the important part of saving shit, is getting rid of the bad stuff. Anyway, if all of this crazy old school, big wide parallel bus stuff has your juices running, you should check out Maya Posh's article that came out just 2 days ago. It's You've Got Something on Your Processor Bus, The Joys of Hacking ISA and PCI, which are, along with IDE, the other old school big parallel buses that used to be in computers. She finds that they're tremendously accessible these days in exactly the way that Daniel did when he's doing this IDE ATtiny project. Go check it out. It's surprising that what used to be high-end mystifying computery stuff is now really just, get a bunch of buffers and some I2C to parallel adapters and code some stuff up on an Arduino.
So once you do have your homebrew Walkman disc player, Discman, I should say, all bootstrapped up, you can give yourself a little dance party. And if you don't know how to dance, you can learn how to from the robots at Boston Dynamics. I'm certain anyone listening to this show already saw this video, which came out last week, but of course we didn't have a podcast, so we're talking about it today. It's incredible, I gotta say. If you are a roboticist and the marketing team comes to you and is like, we should make people not fear for their lives when they see these robots, what do you want to do? And then you say, let's have them dance to some Berry Gordy music. That sounds like a lot of fun.
Yeah, this is an awesome demo of their capabilities. You're going to talk about it. I'm going to give you the absolute spoiler. The most jaw-dropping moment is when one of the robots, I guess it's a two-legged humanoid, I don't even know what that one's called, starts doing the Running Man.
Oh, yeah.
Think about that from like a kinematics robot design problem. It's got a foot that's like hopping and then landing and skipping and sliding. When we do that sort of thing, we're totally good with it. We're used to balancing on our feet. But this robot has to be doing that in real time with a super heavy thing. The fact that they can get that going and that it works so damn smoothly is really amazing to me.
Yeah, and I'm glad you brought up the kinematics, because that's really what this is about, right? I'm very curious to see how much of the programming was by rote and how much of it is the balancing algorithms that are already built into the robots here. Can you just tell it, like, move your arms and have the end effector start here and end here and go in this amount of time and get a lifelike motion out of that because of the underlying code that they have running? I also wonder if they used some kind of motion capture with actual dancers.
That'd be a great way to do the programming, because like that's got to be lame to have to do all of that programming yourself.
I don't know if there's any other way to do it. I mean, if you look at the kind of the state of the art, movies, video games, anything that's going to have a digital model move in lifelike ways usually starts with some kind of rotoscoping, motion capture, something of an actual life form. And so in this video, you get the two humanoid Atlas robots, which are each about 5 feet tall and 180 pounds, completely untethered under their own power, dancing to the Do You Love Me? And then you have Spot, the dog robot, comes in this robot does like a pirouette, like a four-legged pirouette. And if you look at the article I wrote about this, I put a GIF inside of it, and you can see the pirouette action, which is interesting to me because there's a robot arm that is kind of the neck of this dog robot. And that's a really good way to keep your balance when doing this. So I was wondering if it would be able to do this as well without the arm on there.
Oh, right. Kind of like a dog does with its tail or something. This one's
Right.
doing it with its grippy arm, creepy neck thing.
Yeah, so the only thing that's creepy about it to me is that, at first blush, it feels like you could go on the dance floor with these robots, but certainly not. I mean, like,
No.
they're not sentient. They're not going to be aware of another dancer out there. If something goes wrong, you're going to be next to these very powerful machines that have a good amount of force and mass behind them. But I could see, it's definitely a good marketing tool because everybody is talking about it, not just the geeks on Hackaday.
Yeah, but totally go back and look at the video. You can see like X's on the floor where they start them off and they like started the choreography. And then look in the background, right? Because they're in a completely sealed off from anyone cage. This is like robots in a cage dancing. No people are anywhere nearby. And I was actually expecting a super cool reveal at the end, but a little disappointed not to get it. Who is in the cage filming these robots as they're doing their dance? You know it has to be on another one of their robots, right?
Yeah.
And so I was hoping that they would have yet another camera that would point at the main camera robot and like it would break out dancing or something too. I think they missed a trick on this.
It's a secret, not announced mech that you can ride inside of. And it was Spielberg running the camera,
Exactly.
I do think that it's impressive. I mean, the thing that we're looking at here is the mechanics of the robot and the ability to write code to get those mechanics to work in very, very interesting ways is fleshed out. I think, like self-driving, the problem is putting it into an actual situation where you need it to do something becomes very, very hard. And so who knows when they'll be able to crack that nut. But I look back 10 years or 11 and a half years, I guess, to the first time that we were covering the early Boston Dynamics spot robot. And then you look at now, and it doesn't seem like a very long time period for how far they've come.
From horrendously expensive robots doing nothing crazy but dancing to a slightly overdone way to handle a very serious problem. How do you water your Christmas tree? This is the Internet of Christmas tree watering. RK's project here is really nice, and not because of the Internet of Christmas tree watering part. I want you to just leave the Internet of Things aspect of this project. The kind of hook it up to the internet, web services, all of that back-end stuff is interesting, but it's also well-trod. In this case, what I thought was really neat about the hack was his trying to make a DIY capacitive water level sensor. And so that's the part that really spoke to me. And in particular, because he starts out with some failures. A capacitive water sensor is really just two pieces of metal next to each other, and as the space in between them fills up with water, they have less and less capacitance, right? So it should be super easy. And he starts off just sticking plates in water, and of course the water conducts, and well, that's the end of that. He comes back later with some vacuum sealable food saver bags to waterproof these things, and does an extremely nice write-up of how then passing a high-frequency square wave through these and then down through another capacitor makes essentially a voltage divider, and then how you can read that off. And then he does a whole bunch of testing, which I thought was really nice, because if you've ever seen these capacitive sensor, water sensor things, or I've tried to make a few for like plants as capacitive moisture sensors, it's really hard to know what you're actually getting out of them. I mean, you can see this value that goes up as you pour more water into it. But what does it mean? Where's the right place to stop? When do I stop watering? When do I start watering? It's really hard to know, and it looks like it's really nonlinear. In this case anyway, he is just testing the water sensor in a cup because the idea is to keep the pot that's inside a Christmas tree stand filled with water. So it's kind of a simpler problem than the plant watering problem. But I do love that he goes through and calibrates it with respect to water depth in the cup and then, what kind of voltage he gets off of it in terms of ADC counts on his microcontroller. And he complains that it's nonlinear, but man, I look at it and it looks really awesome to me. And then the rest of it is just make something that warns you when it's out of water and fill it up yourself.
It needs to play dying tree sounds.
No, what it needs to do is push it off to the cloud. But
a braver hacker than I would hook it directly up to a solenoid that is hooked to a water main.
Yeah, right.
And then you just hope it shuts off when it's supposed to shut off. Right. The application here. I mean, if you're going to talk about Christmas tree watering, I mean, there's a million different things you could do. Right. You could use an ultrasonic sensor. You could use a float valve, which is the traditional way of measuring water levels, and it sidesteps, like you said, the problem of a plant in soil is a much different problem than a plant in a pool of water.
Right.
But none of that really, like you said, it's the lab work here that is the most interesting. And so, don't miss this one because it was about Christmas trees. Go look at it because it's about characterizing a problem and then testing to see if you solved it well.
And what's funny is he does run it and does push his data off to the cloud, get it down on a Grafana website and, all of this. What's nice about the graphical presentation of it, I poo-poo the internet and I really don't think this data has any business going outside of your house, but it does provide you this really quick and easy way of graphing your data. And when he does that, he picks up some glitches in it that I think even at the end of the article, he doesn't fully understand where they're coming from. Even though he did all this kind of upfront testing, he's still got something else going on. Honestly, my personal experience is that these kind of capacitive water and moisture sensors are just kind of creepy. They're always a little bit glitchy and have never served me particularly well. I've gotten them working slightly less well than he does in this one. So good for him.
There was a bit of black magic shown off in one of the articles this week. It was a tip submitted by Keith about a linear actuator that doesn't need the traditional room that you would need for something. So if you think about a linear actuator, it's like a broomstick, and you could use that broomstick to push something across your desk, but you always need enough room for the entire length of that broomstick to come back towards you, or else, it'll run into you or run into the side of the wall, or it'll run into your office partner or something. And so you have the limit of how far the linear actuator can go kind of doubled because you need to have the same amount of space for storing it when it's not, extended. And in this case, an invention called Kataka by Jens Sorensen does some weird metal pole zipper action is about how I can describe it. The actuator itself is like the size of a computer keyboard. And then over where the numpad is on the side, there would be a rod, about the size of a euro coin or a quarter that would just rise up toward the ceiling out of your keyboard as if by magic. And the way that it's done is that there's a chain coiled up inside of the keyboard part of it, and it goes through a special mechanism that kind of pivots those into place, and about 4 of them will form a cylinder, but each of them is offset vertically a little bit so that each of the 4 pieces is like a spiral staircase getting a little bit higher, and out of that you have the actuator rise into existence.
Yeah, you know what this totally reminded me of was a few weeks ago, we ran a 3D printed rigid chain mechanism, which was a Greg Zumwalt 3D printing
I remember that one.
oddity again, which is kind of like the same thing. That one literally goes up like a zipper, whereas this one kind of goes up by inserting wedge-shaped pieces into kind of a spiral as it spirals up. And these are both kind of similar, interesting kinds of mechanisms. And I wonder if Keith, who tipped us off to the Kataka mechanism, did that because of our article about the rigid chain one before. But both of them are just so... I mean, I'd never thought of this problem before, and I'd certainly never seen anything like either of these before, a few weeks ago.
The interesting thing is the company seems to be defunct, but back in 2003 when the idea first came out, it was featured in a magazine, and that's where we get some of the background information on this. There's also a patent drawing which helps you understand a lot better what's going on here. it seems to have been plagued by lack of an application for it. So they have a YouTube channel, and you can see like one of the interesting things is like an awning type of sunlight window, and so this could be used to raise that window up. They showed it making a chair go up or down, and it just the killer application wasn't there. But I have one in mind that I saw on the internet, and I put the link to the YouTube video here of a spiral staircase, a spiral escalator in a mall, and it's one continuous loop for both the up and the down, and the stairs can go straight under the floor in order to get from the end of the down to the beginning of the up, and the end of the up to the beginning of the down. This kind of thought of zippering together parts into a cylinder has that application for sure. The other thing that I thought was really interesting was CRJEEA, commenter on this article, talks about a liquid metal antenna. And these are tunable antennas that use mercury in a capillary tube. And if you make the mercury longer, your antenna has essentially become longer by itself. This is a way that you could adjust the length of an antenna without manual intervention.
We must have a lot of ham radio people, because a lot of people said antenna on this one. And if it weren't made out of metal, I would think that totally makes sense. I guess you could have the crazy helical structure itself be the antenna. Yeah. I was thinking you would push up a wire with it, make it out of plastic and push up a wire with it, but you could have it be the antenna itself.
I was thinking to have it be the antenna in itself, except it would be connected to all of the coiled antenna in the base. So you'd have to account that in your calculations. But I think it's really the length of the tower part is tuned to the wavelength, right?
The other thing I thought of course, was actually suggested to me by the title. I was thinking that this should be part of some like magic show. Like this has to be useful for some magician to pull off some goofy illusion where like, there isn't room for the rest of the broomstick, but then all of a sudden it assembles itself out or something.
I'm with you on that. The disappearing magic wand, like you said, the broomstick. Yeah, there's got to be something. I'm not creative enough to come up with the magic props, but I love the mechanism. I think it's really cool. And we're going to look at another pretty cool spiral mechanism in a few minutes.
Dum, 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 dum. Which one is that? Oh, I see. Yeah,
we'll get there. We'll get there.
Yeah, just keep me in suspense, man.
Keep everyone in suspense. I
have to go look at the show notes to figure out what it is. All right, well, let's turn away from amazing mechanical constructions for a second. We'll talk bits and bytes. Stefan Wagner's improve ATtiny timing accuracy with this clock calibrator is just a really simple but really slick little device. I don't know if you've played around with ATtinys, and I think all the AVR family of microcontrollers. They've got an internal RC oscillator, and it is kind of roughly runs at 8 megahertz or 9.6 on the ATtinys. But it doesn't really, and it kind of depends on temperature, and it kind of depends on a bunch of other things, and it also depends on an internal calibration that it stores in EEPROM. And so if you actually care about how fast these things are running at your target voltage in your room under your conditions, you can calibrate these things. The dark side of that is that if you calibrate them so badly by accident, you can end up with a chip that won't flash at all because it's so badly out of sync that you can't connect to it and get new code into it. And that's the point of what his device is doing. It's a fuse setter and oscillator calibrator and basically ATtiny 85 rescuer. And that makes it an awesome little device to have all on its own. Just the finish on this project is so nice. You plug the thing in there, you select the correct option using 3 different buttons and an OLED screen. And actually another ATtiny that is in the device programs your victim, fixes its oscillator up. It's got an onboard significantly more accurate crystal oscillator. It can also calibrate the victim ATtiny's oscillator to match the crystal oscillator, which is probably a lot more accurate. And this is a great, cheap way to make sure that all of your AVR-based projects are running to speed, even if they don't have crystals.
I never really spent much time calibrating the Tinys. I know I did it at some point in hopes of getting a real-time clock that was somewhere close to time, but boy, they drift with temperature throughout the
Yup.
day. So even if you calibrate it with this, it's gonna move.
It's funny you should mention that. A friend of mine once wrote and was like, hey, if you were doing this, how would you solve this problem? I guess he had an art piece that had to do something at a particular time 9 months in the future. But it didn't have to be particularly accurate. It wasn't like to the minute. I think it needed to be accurate to the day or something. And he's like, how would you do this? And because I'm an idiot, I said, I would just take an AVR and do it. And so I started benchmarking this. And like you say, the internal clock is so off, it's ridiculous. And I'm like, okay, well, I'll try calibrating it. And so you pull down the application note about calibrating the internal oscillator and you start doing that. And then started counting how many counts I could get in a day. And then I let it run for a couple days and, it starts to drift horribly. And then I'm like, oh, man. So I ended up with this horrible routine that would try to figure out its temperature from the internal temperature sensor. And then I guess it was just adding and subtracting counts to a second.
Right. I was going to say, you
Get
can't
that
change,
to run.
You can't change the calibration bits at runtime, can you? Aren't
I
they
don't
fuses?
know. Can you set the OSCAL registers at runtime? I think
It
you
doesn't
actually
matter.
can, but I'm not
doesn't
100%
matter.
sure on that. Anyway, the routine was just count up to some 16-bit number and then call that a second. And this was just, adding a couple bits here or there off of that to make the seconds longer or shorter. And I got it pretty darn accurate at the end. And then, like you said, a week later, it was hotter in the summer, and the thing just didn't run very well at all. And so, yeah, I stand corrected, Alberto. The right answer is just buy a real-time clock module for $1 and don't worry about it.
But this has got to have utility because the calibration register exists. So there is a legitimate use for this, and this is a pretty eloquent way to automate it so that you have less data sheet digging to get your tinies. Yeah, to get your tinies working.
Yeah, no, and it's a super cute idea. And I've always been a kind of anti-engineer minimalist. Everyone else is if you're going to do serial with the ATtinies, you absolutely need to have a crystal on it. And I'm like, bah, just calibrate it and you'll be fine. And actually, for me, that's always been true. But I don't recommend it for you if you're doing super critical projects out there in the wild.
You wouldn't want to sell a product and then have to deal with the customer support based on that choice.
And anyway, the idea of this project is basically just to rescue ATtinies that you've screwed up the oscillator calibration on so bad that they won't talk to you anymore.
I promised more spiral mechanisms, and I will not disappoint. Oleg Pevsov has been milling his little heart out on a bolt that threads in both directions. It is incredibly satisfying to watch the finished product here. You can get a nut that is threaded left hand and another nut that's threaded right hand, and they will both go onto this bolt. But the real killer app here is the nut that is also threaded in both directions and goes on the bolt that is threaded in both directions, and your mind will be blown by that a little bit. Now, what do I mean by threaded in both directions? If you look at this, it looks like a knurled handle for something. So if you've looked at knurling before, it's where you take a smooth rod and you etch diagonal, basically thread patterns into it so that your skin has something to grip onto when you grab it. This is tiny little knives in the shape of elongated pyramids, because what ended up happening is a lathe was used to mill the threads into this bolt in one direction. Then it came back and milled them in the other direction so that they cross and they cut the majority of the thread out. It's kind of interesting to me that this works at all with the bolts that are threaded in one direction. It's just wild to see it working with the nuts that are threaded in both directions, because in the demonstration, he goes to tighten the nut, turning it righty-tighty. And then at the end of it, he gives it just a tiny little shove and then keeps turning it righty-tighty, and it starts to unthread from the bolt as well. And I think my favorite part of the entire video series was when he did that, he plays a confused dolphin sound. And I was like, that's what my brain's doing right now. I don't see how that works, but it certainly does.
I don't know if I found this to be so confusing. I mean, in some sense, he cuts right-handed threads into it, and then he cuts left-handed threads into it. And so It's hard to say I'm surprised that a right-handed nut works with it and a left-handed nut works with it. I mean, I saw him do it, but then he goes and, like you say, he makes the right-handed and left-handed nut. And I was trying to think, like, I know why right-handed threads and left-handed threads exist. Like, you know, your bike pedals are held in with one so that when you pedal, you don't unscrew them, right? And so it makes sense to have them to have the option of them going in one of both possible directions. Why would you ever want one that goes in both? And I think you pointed out why you wouldn't ever, which is that no matter which way you turn it, you end up loosening it.
Yeah, MC Escher has entered the chat, Elliot.
Yeah, right?
Well, I think when you have both the nut and the bolt threaded this way, I look at it and I can't believe that there's still enough contact surface between the two of them for the threads to actually work. And I suspect if you just kind of shook your hand a little bit, you could push the nut straight down on it, but maybe not. It's hard to say. At any rate,
you think you just go wiggle back and forth like the width of the teeth, and you go woodgy, and
yeah, a third of a millimeter left and right.
I bet you. I bet you could, right?
Yeah, but it's really interesting to watch the video. I've been watching a ton of these milling videos. I'm going through old Tony's back catalog and ClickSpring's back catalog, and so I really like seeing this and seeing the methods that are done. In this case, the lathe that's being used has a router attached to it that's used as the thread cutter, and that, of course, was a home-built attachment. That's interesting to watch. There's like 4 different versions of this bolt that are cut to kind of get the accuracy that was looking for, and it's a great thing to add so that you can, you know, sit on the couch and veg out with some awesome chips being made.
My 3 quick hacks this week have something in common, and that's that they're all deceptively simple, but they have little nuggets in them that you should pay attention to. First up is Ben Eater's breadboarding tips. Ben Eater makes 6502 computers on breadboards, and unlike what would happen if I made a computer on a breadboard, it's not just a horrible tangle of wires. A lot of the viewers of his tremendously educational YouTube channel have written in asking how he does it, and he's finally come through. The answer isn't really all that surprising. He's just really careful. He cuts them all to the right length, but the way he does it, the way he measures out the wires on the breadboard was actually interesting to me. He uses the breadboard hole raster to measure out an extra 0.3 inches before he strips it. He's got a lot of little tips like this, including how to make large buses of wires that all have to go together bundled up over a chip. If you're doing a lot of breadboarding, you should give this a look. Next up, never forget to turn on the cooker hood again. Peter has one of those stove hoods above his stove and doesn't want to have to turn it on himself when he's burning something on the stove. He just wants it to go on all the time ahead of time. And this sounds like a simple project. I love the approach he takes, which is to put a current transformer on the electric cooktop and then have an Arduino connected to that sense when the stove is on, and through some relays turn the hood on. Things got ugly because the easiest way to turn the hood on was actually at the breakers down in the basement, and he ends up running the signal over phone line down to the basement. And of course, there's a lot of devil in the details here, but it's a cute solution to a fun problem. And last up, Patty's Lab. Heat turns 3D printer filament into springs. Again, sounds simple. You take a bunch of 3D filament, you wrap it around a mandrel like a screwdriver head or something like that, tightly wrap it, and then pass a flame over it to anneal it, let it cool, pull it off the screwdriver, and then boom, you've got little plastic springs. What's cool about this video then is that Patty goes and tests them and puts them through springy tests, and the compression springs go through at least 18,000 cycles of pretty heavy compressions without breaking. He does manage to break the stretchy springs, the pull springs, but they all break at the little part where the ear comes in at the end. They don't break in the middle of the spring where you'd expect. They break on the edges where there's been the most stress, suggesting that this is still a valid idea, but you just have to work on making those loops a little more robust. What is pretty impressive to me here is that he's not stretching these just a little bit like you should with springs if you want them to last for a long time, but he's stretching them like double their length, and that they still last for 5,000, 10,000 iterations is really pretty cool.
First up on my list of quick hacks is 76-bit trombones led by the big MIDI file, a horrible pun on the Music Man by Matthew Carlson. He was writing about iSax's project, which is a robot trombone player. This is a really tricky hack because recreating the buzz of the human lips into a mouthpiece would actually create the sound is a difficult challenge. A silicone mold of lips was used for this from very questionable sources, but it works really well. The challenge here is it's not just getting the buzz to happen, and it's not just getting like a certain amount of air pressure, but it's changing the tightness in that buzz, changing the shape of the resonant chamber of the inside of the mouth of the player, and all kinds of other things. iSax says it's an incredibly over-engineered noisemaker, but I think it's delightful, so check it out. If you are interested in 3D printing something that is going to touch food or water, you are going to have a ton of people tell you that food safe 3D printing is not a thing. But if you're looking for a way around that, you can use your 3D printer to make porcelain objects. And that is by 3D printing a form, making a plaster mold from it, and then slip casting porcelain from that. This is exactly what happened with Thoughtful Ocean's project. In the article, dog bowls show the versatility of ceramic slip casting. And finally, we have how a quadriplegic patient was able to eat by himself again using artificial limbs. Maya Posh wrote this article about Robert Buzz Chmielewski, who is a quadriplegic and had a couple years ago 6 different matrices of sensors put into his brain, and has been working with researchers ever since to turn the output of those into the input for a set of very advanced robot arms. This is a great uplifting way to start the year 2021. Go and look at this video and see his robot arms using a fork and knife to cut up food and feed himself. I love to see technology applied like this. It makes the world a better place, and hopefully it will make Buzz's life a lot more fulfilling going forward. So congratulations to him and to the researchers. It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday writers. Elliot, what did you choose?
This week, I picked all the good VR ideas were dreamt up in the 60s. Donald Papp goes through kind of the history of VR, and it's really neat because a lot of the kind of fundamental ideas of what we now think of as virtual reality were developed in the 60s and were completely impractical back then. But you have to imagine, both computers back in the 60s and screens, displays back in the 60s, super limited. And yet at the same time, researchers, mostly in universities, were thinking already, how can we get computers and displays to, interact with us in a meaningful way? And I love that this article goes through the things that did happen that were crazy, out of the box ideas in the 60s that did happen in modern times, and then those that didn't. There's the most marvelous one, actually. Ivan Sutherland's Sword of Damocles was this. It was honestly surprisingly like a pair of VR goggles now, except back then, to get all of the data and the images into your eyes, it had to be connected to this huge pipe that went up to the ceiling and was on this crazy track system, so that you could walk around and have this headset stay on your head as you walked around the room. It required this entire, subsystem that was built into a room and came straight down at your head, hence the Sword of Damocles name. Things like that, actually, head tracking and following you around the room and stuff, did actually kind of come to pass. But then other things didn't, like force feedback we don't have, and I guess Donald mentions holodeck-like stuff, but yeah, we're not anywhere near that.
It's really interesting to take a look back on long time periods of technologies like this, because I think we move the goalposts so frequently. And if you think about the accelerometers in your phone right now are so incredibly amazing, But everyone just looks at it and it's like when you turn your phone, the screen orientation turns. Of course it does. Of
Yeah,
course that's
right?
the way it works. You
Yeah.
know, because everyone has that and we forget how amazing that is. So when you talk about like head tracking, it's not as easy to relate today at how new and innovative that is because we have in our hands all the time things that can sense motion and can track motion. And they're not as good as, you know, like the like Valve's system for tracking with their lighthouse sensors and really getting that precision so that there's no difference in how you move compared to how the video in a headset moves. And especially Donald mentions no lag. You know, if you can reduce that lag
Yeah.
down to the point where you don't notice it, the thing that he used in his article, I'm not sure if it was Donald saying it or someone else, but it becomes like looking through a window into another world rather than becoming a display that you're putting in front of your eyes. And I think that is a magical distinction and a really great accomplishment, even if we don't have holodecks.
It's funny you mentioned those because a lot of those were kind of enabled by good, cheap gyroscopes. And that used to be really hard, even like 10 years ago. And so Donald mentions, you know, VR in the 90s where you'd move your head and then it would kind of maybe jerkily follow you around if you're lucky. As you know, you'd kind of pan across the scene. And that basically has been totally solved. I think the one that hasn't been solved yet that's most interesting, that's been on the list of things VR should do since the 1960s, is super good eye tracking. So like now when you move around in VR, you move your head and it's easy to sense where the goggles are pointing again because of better gyros or an external system like Valve's Lighthouse like you're mentioning. But then following where your pupils are going is a lot more difficult. And that's something you'd want to do because, you know, when you look around the room, you don't always turn your head. Sometimes you just move your eyes. And that would be really good to have that sort of stuff worked out better. And we're on that edge right now. So my guess is that this is going to go from one side of his list to the other side in the next 5 years or so. But we'll have to see, right?
So where are you on VR? Are you super excited about this? Are you lukewarm? Could you not be bothered?
I'm lukewarm, but I think it's fantastic. Which is to say, like, it's not for me. I don't see myself spending a lot of time in virtual worlds. I don't play a lot of video games either anymore, man. I used to play a lot, and I don't anymore. But I've messed around with VR a bunch, and I've used some people's VR systems that are just mind-blowing. So I definitely see where it's coming from. It can be really, really awesome. My God, there's some pretty convincing like there's this one, it's a cliche demo, I think, but like there's this one where you go up a super tall elevator and you walk a plank basically. And if you set this up right, what you do is you put a 2x4 on the ground in front of the person who's wearing the VR goggles. And so in the VR world, you're walking this plank that's like 70 stories up outside of this skyscraper. And in the real world, you're actually trying to balance on a 2x4. And I've done it myself. It's absolutely terrifying. I've seen other people do it who are like at least as terrified as I am. So I know I'm not alone. It's just a fantastic, completely compelling fake reality, right?
Yeah, I guess I've never tried anything that interesting. I've tried a few of them and I think they're fine. I don't know that I'd want to use them like for teleconferencing.
Oh no.
And I don't know that I like being closed off from the environment while I'm playing video games.
Yeah, my favorite thing is like these electronics conferences or something where you go there and there's a VR demo. And so what you get is this couch, you know, a big long couch with a bunch of people in suits all sitting there with these things on their heads, looking like complete idiots because in their minds, they're going through something entirely compelling and real and interesting. And from the outside, they're just sitting on this couch in the middle of a convention hall. And you're like, I could come up and take your wallet.
There's that iconic video or iconic photograph of Mark Zuckerberg walking in during a developers conference, I think it is. And it must have been, you know, after Facebook bought Oculus or something, but everyone in this audience of hundreds and hundreds of people is wearing these goggles. And so Mark Zuckerberg is walking in and nobody realizes it. And
Nice.
I just, maybe I had the details wrong on that, but that's the gist of the image. And I just look at it, I'm like, yeah, that's the thing is like, I'm not looking to escape the reality that I have right now. But, who knows
Every
if
once
it,
in a while, man.
I think training wise, definitely. I mean, imagine all of the really difficult things that have been made better by training simulations, like being a pilot. So I think there's a ton of situations where professional training where you can make the job safer, make it better, make it faster by putting someone in a very, very similar circumstance. There's a lot of utility there. So I'd be excited for that. For me, there's just the jury's still out on convincing me that VR is the entertainment thing that's really going to make me happy.
I think the content for virtual reality is all in this really infant stage. Even if you think about that demo that to me was entirely compelling, it's like the equivalent of that first early cinema movie where the train comes out of the tunnel at the audience and the audience all gasps in like 1920 or whatever, right? Like it's this kind of, here's a possibility of the medium and here's how it's going to shock you level right now. And I think that's a little bit where we are. I've seen some cool VR art and some games that are actually pretty good. So, in terms of video games or these kind of cinematic, artistic things, I think we're getting close to where it's really interesting now. For training stuff, I don't know, think about a pilot's cockpit simulator. It's nice to have them able to actually put their hand on the lever and, anything that involves physical movement. You really want the people to be able to grab the thing and not to do virtual reality, manipulate the thing with the funny wand you've got, right? Like with the avatar of a hand. And that really isn't the same as taking the motions and doing it yourself and developing that muscle memory or whatever. So I'm a little reticent about VR in training, actually. I think I slightly disagree with your view on that one. But for video games and for art and having fun and making crazy demos, it's pretty cool.
It's going to be you and your buddies at the movie theater, except for you're just on your couches.
This is what they said about the Walkman, too, is that we're all just going to be zombies in the train not talking to each other. And that totally happened.
Yeah. This dystopian future has been brought to you by the Hackaday podcast.
Exactly.
All right. Well, the article that I chose this week is one written by Jenny List. It is a review of the Pine 64 Pinesil. This is a soldering iron in pencil format. If you're familiar with the TS100, which is a portable, I believe USB powered soldering iron, this is similar, and Jenny gave it a run for its money. It was announced to be available at the end of December. It's something like $25, and then it uses the same tips, the soldering tips that have a built-in temperature element, heating element in them as the TS100. So you can swap those out. You can get a set of fine tips or a set of heavy tips. And the verdict from Jenny is that she can't find something she doesn't like about this.
Yeah, Jenny's our early adopter of random portable soldering devices, I think. She's like jumped on all of these. Before this was a serious proponent of the TS100, and then she bought some cheaper knockoffs of it and found them just not quite as good in a bunch of different ways. There's just a couple little details that make this one a little bit better, and I could totally see that.
So it seems like the power is the first thing to think about. You can power this from either a barrel jack or a USB power delivery. So that's the USB PD standard for USB Type-C. It can go up to 65 watts, which is bonkers. Somewhere between 17 watts and 65 watts. So if it actually gets up to that point, that's plenty of horsepower for melting a little bit of solder. And
yeah, that's a right soldering iron.
Yeah, so incredible. If you're asking yourself, like, how do you do that through USB-C? I mean, fast charging laptops these days takes really beefy power supplies that are by and large being transitioned over to USB Type-C. And so if you have like a MacBook that you're carrying around with you anyway, there's your power supply for your soldering iron. So you just have to then throw this along in your backpack, which is pretty cool. It has a little OLED screen There's an accelerometer in there that lets that screen automatically adjust with your right-handed or left-handed so that you see it upright. And then it also will sense when the iron hasn't been moved, so it can go to sleep. It is supported by Iron OS, which is an open source operating system for these sorts of things. I think the greatest thing about it, as with all of the offerings from Pine, is it's open source. So you can go and they actually have a guide on how to tear the thing down, which is refreshing. Please, non-open source companies, adopt this. I think it's a great thing. You can go and look at the schematics, the design files. You can look at the code. Everything's out there. And really the only problem with it is people that want to get their hands on it can't because it's out of stock.
Yeah, 65 watts is not bad. I have to say my daily driver is it's a big desk. It's actually a Chinese Hakko clone. It's 80 watts and, that's plenty. You never need more than that. And 65 is, really almost there. This is not a compromise in terms of how much power the thing can put out. The thing that's different between my old rugged soldering iron, which must weigh 1,000,000 pounds. I mean, it has an actual power transformer in it, right? Iron cores and all that. And this thing is that A, this one is super light, and B, this one has computer control. And it might sound like putting a microcontroller in a soldering iron is a silly thing at the beginning, but it heats up so fast and has an accelerometer in it. You can put it down and have it turn off, and pick it up and have it start up again, and put it down and have it turn off. You will never leave your soldering iron on unattended again or light up a piece of paper on your desk. It's a kind of really compelling idea. I don't need a new soldering iron at all. But like you said, if it were in stock at the price, I would consider picking one up.
Well, I don't know. Maybe I have a SparkFun version that I think is like a Hakko clone. And it was a wonderful gift from my wife for Christmas, and I love it. Before that, I had the Radio Shack Fire Sticks. I think I had a 15 watt and a 30 watt or 40 watt. I have both of those still. It's good to have multiple irons for desoldering. But yeah, this has been wonderful, except for all it has is a rocker switch on the side to turn it on or off, and then the temperature knob on the front. And so that thing is burning at 300C all the time. And it would, what are the brand of irons that when you put them into the stand, they shut off?
Oh, I don't know, but that's clever.
Yeah, is that I know everyone swears by the Metcals. I don't remember if that's the Metcal or not. But, it would be a lot less tip maintenance if you weren't just burning that iron the entire time that you're trying to strip wires and get them into place and get your third hand in there. And then by the time you pick up the iron, the tip is all oxidized and needs to be cleaned off again, which is fine. It's the way it is. But yeah, it would seem that there's no lack of space for innovation there.
Mine has the same control set that yours does. It's got an on-off switch and a dial. And I'm like, that's all you could ever need. But I have literally, in my life twice, left it on overnight and woken up the next day and come up here and wanted to solder something and found the soldering iron on.
And you went, oh my God, that's scary.
One of these times was not overnight. We were actually gone the whole day. We were out of the house, far away. The good news is nothing catches on fire. It's in the soldering iron holder. No worries. Tip wasn't even super badly oxidized. A couple dips in the little brass spongy thing and we're good to go again. But yeah, do not tell my fire insurance company that I did this.
I wired the outlets at my bench into the lights at my bench so that if you turn the lights off, the outlets go off too. So if you forget your iron on, problem solved.
That's not a bad idea. I was going to say I just always do it, but actually twice I haven't. So yeah, sketchy. But my house hasn't burned down yet.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you see something cool or you've done something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. But I failed 3 out of 4 CAPTCHAs just now.
Maybe you're not a human.
Oh, horrible. Let's see. I'm going to say that more nicely.
Wait for unsavory till I get to quick hacks, my friend. I think these last 2 things are really good.